So let's talk about quantum numbers. So the first one is principal quantum number. First one is principal quantum number. And how is it represented? It's represented with the letter N. If you want to get like a visual about it, or just think about it when I say main shell or subshell, what does it mean? So think about it like this. There is a nucleus which has protons and neutrons in it, in the atom. And think about electrons located in three-dimensional spaces like this. And these are your main shells represented with the letter N. So the closest shell is N1. The next one is N2. And I'll talk to you about rules in just a second. And each of these main levels is further divided into subshells, which we represented by L and M sub L, right? In fact, if you go by the rules, this will have only one subshell, and I'll talk to you about the rules again. And the second shell will have two subshells like this. So each shell will have its own subshells, right? So think about it like that. So what is some of the information you get from principal quantum number? One of the things you will know from principal quantum number is the energy. If you know which level or which main energy level the electron is located in, you can calculate the energy using En. Formula En is equal to, or energy of an electron located in the main level N is equal to negative 2.18 times 10 raised to 18, 10 raised to negative 18 multiplied by 1 over N squared. So if N is 1, in other words, if we're looking at this one, this N will be substituted by 1. If you're looking at the second main level, this will be substituted by 2, like that, right? So energy is one of the informations that the principal quantum number will give us. The other thing also are the rules. Now, remember, N cannot be 0. N has to start with 1. It will go 1, 2, 3, meaning the first level, which is first main level, which is closest to the nucleus, is 1. The second one is 2. The third one is 3. N cannot be 0. N cannot be negative. And N cannot be a fraction. In other words, you cannot say, well, the electron is located in N is equal to half. That's not right. It's not correct, right? So N starts with 1. Now the other thing also you have to remember is that when an electron jumps from one level, let's just call it the initial level, it's located in a certain level and then it's going to a final level. So when the electron moves from the initial level to the final level, the delta E value, the change in energy, E final minus E initial, as in final energy minus initial energy, can be calculated as 2.18 times 10 raised to negative 18 multiplied by 1 over N final squared minus 1 over N initial squared. So let's say the electron is jumping from fourth level to second level. So your energy difference, delta E, would be negative 2.18 times 10 raised to negative 18 multiplied by 1 over 2 squared minus 1 over 4 squared. So this would be the difference in energy. So this would be the energy, in this case, energy liberated, because it's going from a higher energy level to a lower energy level. And if it was going from a lower to a higher, it would be energy absorbed.